So using Markovnikov's rule, if we added water to this alkene, what's going to happen? What's that water going to do? It's going to split apart this double bond with some addition, and it's going to add an alcohol and a hydrogen across the double bond. But how do we know where to put the alcohol and where to put the hydrogen in the water? That's what Markovnikov's rule tells us. We put the alcohol on the more highly substituted carbon, which is the carbon bonded to more carbons. So we can see this carbon is bonded to 3 carbons, therefore it's tertiary. Whereas the other carbon attached to the double bond is bonded to 2 others. So then that's a secondary carbon. Okay, so that tells us add the hydroxide, or the OH, to the more highly substituted carbon. Another way of doing it is to add the hydrogen to the carbon that has more hydrogens on it already. So this is pretty clear and straightforward when we have a clear difference in the substitution of the carbons. But let's do a new molecule now. What if we had something that was symmetrical, like this ethene or ethylene? Either name works. So if we were to add water to this ethene, what would happen? Well, we could see that the carbons are both primary. Each carbon is attached to one other carbon. So what side do we add it to? Well, it doesn't matter which side it goes on, because if we added it to either the left or the right side, it would just flip in 3D space. The molecule, remember, is floating around. In real life it's 3D, whatever. And so this molecule is identical to the other form, where if we added OH to the right side, and remember, would there be 2 different names for this molecule? No, if you remember naming, these would both be just ethanol. So this is for when the starting molecule was symmetrical. The ethene was symmetrical across the double bond. So this was ethanol. So there's just 100% ethanol. So there's no major or minor product. Compared to the first example we did, this would be just the major product, and then we would have a minor or smaller amount of the alcohol in the secondary carbon. Now, what if the molecule was asymmetrical? So the simplest example is actually 2-pentene for asymmetrical double bond with equal substitution across the double bond, meaning this carbon on the left side of the double bond is secondary because it's bonded to 2 other carbons, and the carbon on the right side of the double bond is also secondary. So what does Markovnikov's rule say when we add water, or we could also be doing this with an acid halide like HCl or something, but just for making an alcohol, what's going to happen? Well, we're going to get 50-50. There's really no major product here. They're both going to occur in equal amounts. So 50% is going to add to the left side, and 50% is going to add to the right side. And you can see these would have different names. This alcohol is on carbon 3, whereas this alcohol is on carbon 2, starting from the right-hand side, in equal amounts, 50-50.